Good enough? Hello, we are Team Catstone, and here's our product, a Lending Paw. This project has been supported by, has been approved for animal testing by SFASU's Animal Cruelty Board. I am Acacia. I'm a mechanical engineer. I'm a team lead. I was also in charge of a couple of other tasks.
I'm Tony. I'm mechanical as well. Help with the production of prosthetic along with leading patent research.
And I'm Caesar. I'm mechanical engineering as well. I help with the design and the production of the prosthetic as well as the market research.
Hi, I'm Brittany. I am an electrical engineer. I helped with the production of the program and presentation aid.
We also have another teammate named Trey. He is not here right now. He is the best. I was not cooking. So whenever we were first given this project, this will be the small file. We were given a problem statement, which is basically Trey is missing a leg, and if the videos are playing, you'd be able to see that compared to a normal cat, that causes instability in how he walks. And then we were just tasked with creating a very easily manufactured cat prosthetic that would not hinder any of his movements. And we decided that we also wanted to try to market it to veterinarians and people who were interested in doing this for their own cat who are familiar with 3D printers, because that way there'd be another alternative that can be recommended whenever somebody goes into the vet to try to get their cat a new prosthetic leg. And then there's also a list of customer requirements that were provided to us that, as you can see here, they were provided to us by the customer about things that they wanted included in their product. Just bring the computer up here.
Okay.
So the way that we calculated the market was that using a relationship that was from 2012 from the AMVA.org, American Veterinary Medical Association, we were able to create able to estimate about how many household cats there are, which is about 60 million, and then using an estimation about the probability of being born with a malformation as well as the known low adoption rates of special needs animals, we were able to come up with a possible market of 1,200,000. So.
With patents, through research, we didn't really find any patents, whether pending or filed. The only thing that was kind of in the area that we're looking for was a few patents for prosthetics for dogs. However, they really didn't provide much help or anything. Everything that we found was mainly for dogs. And the lowest price that we ever found for any type of prosthetic, just for the prosthetic itself, not including any type of anesthesia or anything any additional cost, was right around $1,000. And as you can see here, the cost of a cat leg amputation is $1,300. So if we were to have a cat that had to have a leg amputated and add a prosthetic, the price would be at a base of around $2,000, and that's just way too much for the average household to be able to afford.
Alright, so initially we had thought about tackling this project in 3 phases, with phase 1 being injuries below the ankle, phase 2 would be injuries above the ankle and below the knee, while phase 3 would be injuries above the knee. However, the further we progressed, we realized we weren't going to be able to tackle anything above the knee, leaving us with just the first 2 phases. This is because our prosthetic is depending on having somewhere to attach it to, meaning the cat is going to have a functioning knee joint, and without that knee joint, the prosthetic would be rendered useless and would simply just slip off. We realized that anything above the knee would be out of our expertise and would require the use of veterinary surgery, which would rack up the medical bill by hundreds of dollars, and again, that's something we're trying to avoid. But we had thought of something more along the top right, which is more like a brace. The only difference, being a big difference, is that ours is going to have a lot more mobility.
So here's the Gantt chart. So we have 2 Gantt charts, one for the first semester and one for the second semester. The first semester consisted of mostly trying to organize documents and get information ready for the second semester, in which we would start to produce everything. The only major notable thing besides the general information is that we did start one task in the first semester, and that was the program, because we anticipated there would be issues with it. Next one. And then for the second semester, as you can see, there are a lot of gaps in our tasks. We just simply did not get a number of things done. And this here is our design schematic diagram. It is used just kind of like the Gantt chart to identify the different parts and the flow of energy. So there is module 1, which is the product customization module. Hit click it. And it has everything including from the input of user measurements up until whenever the program that we were designing would put it into a Cura file. It would modify the document we have, put it in a Cura file that you print to 3D printer. This will be talked about more later. So then we have module 2, which is the product creation module, which includes pretty much all the acquisition of all the different parts. And then we have module 3, which has pretty much any part that doesn't have a numerical value to it, anything that provides comfort or stability that makes the customer and user more, happy. And then we have our final module, which is the presentation module, which will also be discussed at the end. This is going to be used as a table of contents for the breakdown of the ideas of this PowerPoint. So, let's get into it.
So for the HOQ, we just use this to determine our most critical engineer characteristics. And in that order, we have the yield strength as the most critical, along with the weight, and then the grip on the outsole of the paw.
So initially we all came together and decided it was best for every team member to come up with their own design. Once everybody had that finished, we came together again and decided on the best aspects from each person's design and made our final prosthetic, which we wanted to have these 4 key functionalities. The simplicity pretty much has to do with, we wanted the prosthetic to be easily 3D printed and also have minimal parts. Initially we wanted to keep it to sub 5, but the further we advanced, we realized we were going to have to add a couple more, which will later be explained in the PowerPoint. As far as the mobility and lightweight, the idea behind the prosthetic was that we wanted it to have the least amount of material at the cat's highest points of mobility, which would be his ankle and his knee joint. Along with that, we wanted it to be lightweight because the heavier it is, the more restricting it is going to be on his movement, simply because it's just going to be heavier for him to have to move. As far as durability, that's pretty self-explanatory. We wanted something durable that wouldn't deteriorate due to any scenarios that it was in. And if we don't have a durable product, then at the end it's pretty much useless. And the cost as well was a big thing we kept in mind, which is why we decided not to tackle anything above the knee, just because we didn't want anything that would require surgery. We wanted to keep the prosthetic sub $100, which would not only make for a happy cat, but for a happy family, being that most families would be able to afford something like that.
So as Cedar said, we had to add an additional part. In order for us to be able to fit the thigh piece over the prosthetic, which again is the part that is holding the entire prosthetic in place, we actually had to split up into 2 parts. So we use this to add an emergency release feature that we had been wanting to add. As you can see from the bottom 3 pictures, we have a male half of the thigh piece and a female half. So the emergency release uses sort of like a lanyard function where it has tabs that you can press down and pull the prosthetic apart, or pull the thigh piece apart. However, we did test, and if you apply enough force to the circumference of the inner thigh piece, it will actually pop off without breaking. It will still pop off and you can attach it later. So we weren't able to do a stress test on SolidWorks due to having issues with the part not showing up on the stress test for some reason. So what we decided to do instead is we held the thigh piece up and we wrapped a string around some weight and kind of dropped it from a little small height inside the thigh piece in order to see how much weight it could withstand before pulling apart. And we found that it was right around 3 pounds, which we feel like is a good weight, because we don't want it to be too low, because then Trey could just be flexing his leg and then the thigh piece will pop off. However, we don't want it to be to withstand too much weight, because if his leg were to be caught in a tree or anything like that, he wouldn't be able to generate enough force on the inner diameter to pop the prosthetic off and he'd be stuck. And we really don't want to put him in any situation that could put him in danger like that.
Okay, this is our failure model and effect analysis, where we took parts of the prosthetic and came up with possible failures that would occur and how those failures would affect the prosthetic as a whole. And then we rated them by severity, occurrence, and detection. And then we came up with possible corrective actions that would fix these problems. Here's a couple examples. Our highest RPN, or risk priority number, is a 320, which is for emergency release. A possible failure that would occur would be that if the emergency release would not work, it would stick, or it would hold in place and would cause serious harm to an exasperated cat trying to get away. A possible fix to this is to adjust the design or make sure the design was working efficiently in a safe use. Our lowest RPN, or risk priority number, is a 1, which is for our presentation aid or the circuit. It is the lowest RPN because it is a non-public use, so it's only for this presentation. And so one possible failure that would occur is if the circuit wouldn't work or the prosthetic wouldn't possibly move. One possible fix would be to adjust the circuit or possibly develop a different design for the circuits.
Go back. So in addition to the FMEA, there's also DFM and DFA, design for manufacturing and design for assembly. The FMEA can also be used to identify what parts you can use DFM or DFA tactics on, such as how at the very top there are joints. The easiest example is for design for manufacture. If you were to condense those into being 3D printed, then it would be a lot easier to kind of manufacture, because you wouldn't have to get other pieces and assemble it. So it would also simplify the assembly. And let's see. But also keeping the emergency release throughout the whole thing would also increase the difficulty to manufacture it. So you have to keep those things in mind as we're trying to go through the FMEA as well.
So as far as testing, we decided to do everything with PLA just because it was readily available here at SFA and something cheap for all our printouts. So for the motion analysis, play the video. We did a motion analysis on Trey's walking, and as you can see, he favors his good paw, obviously. And so from that, we just knew that his left foot was going to be a lot stronger than his right, meaning his muscles weren't going to be as developed in his right foot, which we kept in mind when we developed the prosthetic. As far as the fit, we did a bunch of tests on the fit, and that was also a lot to do because he kept gaining weight. So it was a little bit difficult to have one size. We had to keep increasing the size in order to find a snug fit for Trey. As far as the fluidity, we just wanted the prosthetic to be fluid and move correctly with the joints in. And we just pretty much had a set range of freedom that we wanted the prosthetic to be able to do. So for the ankle, we pretty much wanted it to be able to rotate 90 degrees, and it would stop when it would hit the shin piece of the prosthetic. As far as the thigh piece, it was going to be able to freely rotate, which he would obviously stop with his own movement. And so something we had to take into account was the adjustment period, because with anything new comes an adjustment period. And so Trey, we had to initially start getting him ready to have stuff on his legs, so we did that by putting like socks and stuff on him. And the only thing is we underestimated the adjustment period because we didn't account for him taking so long to get used to it, and this is why we have a lack of like photo and video proof of us having the prosthetic on. It's just because he simply just hated having something on him.
So as you can see, our design changed a little bit throughout the process. On the right side, we have 3D models imported from SolidWorks, and on the left side we have a screenshot of what the prosthetic looks from the front. So we had to make some compromises and everything, so we wanted to keep it durable as much as we could, but we also wanted to keep the weight down in order to make it have a more fluid motion, and along with keeping the price down. So as you can see, we added some cuts in that also provide ventilation so that moisture doesn't get trapped into the prosthetic and allow for the padding on the inside to start to deteriorate. We also added a ventilation hole towards the top, kind of looks like a cat's face, little aesthetics. But other than that, the paw stayed relatively the same, however we did have to adjust some of the sizing.
Yeah, the idea was to have a perfect combination of aesthetics and functionality.
Okay, so for the product, okay, so the PDS, it's pretty much a summarization of all the features, qualities, and everything we wanted to have into the design, or that is in the design. So, just to recap, the market, while it is small, in the US alone, it's just about we could estimate it to be about 1,200,000, which is still pretty small given the population of people in the US, but that's still a sizable market. We wanted the product's lifespan to be 2 years, and given all the materials that were considered, did it biodegrade within 2 years, that is a feasible thing that we have met. We wanted our goal price to be about $50 to $100, and the estimated price of production for a single unit is about $5 and some change. And then, so the BOM consists of the 2 rolls of materials, TPU and PLA. TPU is about $30 a roll, not PLA, ABS, right?
Yes.
Yep, ABS is about $20 a roll. And those can produce somewhere between just hundreds of units. so the price is justified. Those two materials were chosen by looking at the quality of the materials safety data sheets and seeing if they were recyclable, if they were animal safe, how well they printed. And then we also have the little features such as the screws that we currently have in our design. We have met a bunch of the design criteria that we wanted that were given up to us by the engineering characteristics and customer requirements, such as it's breathable, it's safe, stable, it has animal safe materials, it's weather durable. Next one. And then throughout this project, we also had to follow a number of legal requirements. One reason why we had to get the SFA's approval was to be in adherence with the Animal Welfare Act and anything that fell under it. We had to get permission to test on Trey, to observe him, if we ever wanted to do anything to him. We also had to follow engineering code of ethics. And then the last thing in our PDS that's really noted is the training. But one thing that there is to note is that there is a difference in training a house cat versus an outdoor cat like Trey. A house cat is a lot more used to being messed with than an outdoor cat is, so it's understandable that Trey got a little angry.
Okay, the program was created to develop or to adjust the prosthetic to every cat's body type and size. And we looked through resources and found a team from Australia called Xerio. The Xerio team was able to develop a code that was able to select a SOLIDWORKS file and adjust the parameters of that file to the user's input, as shown in the video. And we first started out with Microsoft Visual Studios, a Microsoft Premiere software application, but we only got as far as to launch the SOLIDWORKS app. We then looked at the Xerio resources and found Microsoft Visual Studio Code, that is a source code editor of Microsoft. And with a couple of their packages, such as the C# extension and the Xerio Nougat package, which helps smooth in the coding process. We got as far as to duplicate the original code, but ran into time constraints, a lack of experience in this field, and some unresolved errors that resulted in incomplete code. And so we believe the main source of errors that was caused is due to our framework and the Xerio Nougat package differences, but we believe with enough time we'd be able to resolve it. Our presentation aid is a visual representation of cats' movements. And sadly we couldn't have the legend here, Trey, to model it for us. And sadly we couldn't present it for you due to the motors not being able to stick on these rods. But for our presentation aid consists of a simple circuit and program made by Arduino. And so the circuit consists of one Arduino Uno, a breadboard, one joystick, and 2 micromotors. And so it was supposed to move horizontally. The joystick was moving horizontally. It was supposed to move the palm wrist back and forth, and then the vertical direction for the joystick, the elbow, up and down.
Okay, so there were a number of things that we didn't want to get done, as you can tell from the gaps in our Gantt chart. And so personally, as a team lead, if I wanted to try to resolve some of those issues, I would have tried to have been on top of everybody more from the very beginning of the project. Because I had originally tried to give everybody space so they'd stay motivated, except not being on top of everybody resulted in like a landslide of issues that resulted in just a number of things, many of which are on this slide, to not get done.
For our program, I should have contacted Acacia sooner because due to two heads are better than one, and would have gotten a lot more done within that time.
And so the one thing that, for future reference, is we severely underestimated the time for the adjustment period. That's what caused a bunch of our issues, just because anytime we tried to fit something on them, it was always a hassle, and it ended up taking us more time to adjust the fit, make it a lot bigger. Again, it kept gaining weight, so that has to do with it too. But just the adjustment period in general was something that has to be taken into consideration. We should have started that previous semester. Fortunately, we didn't, so that's where we hit a little barrier. As far as the phase 2 of the project, we pretty much our finish, if we finish phase 1, the only difference in phase 2, which would be injuries above the ankle and below the knee, would be to remove the ankle joint. And while it does reduce mobility, it would still give a cat more mobility than anything like a drill and rod on his femur as a prosthetic.
I feel as though we wasted a lot of time trying to get a 3D scan of the molds that we had made. That we kind of used that as an excuse as to why we weren't getting accurate measurements and everything like that. So I would definitely recommend, if this were to be picked up in the future, to just go ahead and measure the cat's paw as it is. I also would follow the advice of a computer science professor that he gave us is, if this were to be taken up by a future group, then to contract the help of a computer science major who has a certain amount of hours in that specific field. Just because the code itself was extremely complicated, and as Brittany said, we didn't have the credentials, we didn't have the experience to be able to deal with that. So if we had somebody on the team that did have that experience, we would be able to knock the code out and have it in our final presentation.
We want to be able to thank some people who actually especially helped us, though, even though it wasn't their jobs. So we had contacted, in the process of getting the molds of Trey's legs, we contacted Ian Collins, who is a SFA sculpture professor. We also wanted to really thank Stephen Garner of the Southside Animal Clinic here in Nacogdoches, because he also helped us. He gave us advice and other things, resources. Then we want to thank Adam Sullivan, who is a grad student here at SFA, who helped us a lot. We drag him everywhere. And then we also want to thank Zario, because we did email them and they did give us resources and advice. And they offered to have a meeting with us, but given they're in Australia, that was a very large time difference. And then we want to thank Trey. We bugged him a lot, more than Adam.
All right, is there any questions?
Is it Michael?
Is it Michael?
Is the speaker on?
The operator we were presenting this whole time and the mic wasn't on.
The mic is on? I
Yeah,
don't know
let's
how-
say they would have had been listening to us.
They just don't
I
sound
don't know how to tell about the speaker, sorry. Yes, I have to figure
it. Well, I guess someone can start typing questions.
Is Trey alive?
Trey is alive.
Yes.
He's got his eyes closed.
No, his eyes are open right there.
And that
He
one?
has very pretty green eyes. He's very much alive.
Can you guys go to the model real quick, the picture of the 3D model for your final design?
Yes.
it.
I see that you used square holes for the connection.
Oh, that was for the presentation day, because the entrance to the motors, they needed something square. So the actual design are circular holes, because we used the post and screw. But for the design, which is the last one we did, the squares were just for the use of the
rods.
motors,
Yes,
for the rods.
give us a better grip for the micromotor to actually move the prosthetic and simulate the movements.
Oh yeah, the actual design was
Is
post and
this
screw.
Is this the prosthetic or is this like the presentation area?
This was a presentation.
Yeah, the model that's on screen is for the presentation aid, because
The only
Yeah.
difference would be that the squares would be holes fit for a post and screw.
the other difference
The paw is
between,
hollowed out.
yeah, and the other difference between this and that and the actual prosthetic is that the very top piece also has an emergency release built into it.
Any other questions?
The SolidWorks files that you all are
Mhm.
creating, where do you normally store them and share them with each other? And I guess your professor as well, Dr. Ochoa. Is that in D2L or do y'all have a?
No, Microsoft
Microsoft
Teams.
Drive or-
Yeah, we use Microsoft Teams for everything. Any shared files, videos, pictures, anything like that was through Microsoft Teams.
Teams, okay. Could you add me to the team?
Yeah,
Yeah?
we can.
Of course.
Yes, sir.
You like cats? You can join.
Yeah, what I like to do is whenever I can, and if there's a project in which we could, 3D print the model that they came up with, we like to put them on display. So I thought if I had access to the Teams folder, I could, over the summertime, make some copies for display purposes and give your team credit and so forth.
Yeah, we have the actual design, we have the circular holes, So we actually have that on there if you wanna do that one
Yeah.
instead.
And we can, we have the screws that we need for it, so we can just go ahead and attach it.
I think I heard that, I'm not sure.
He said he had the screws for the joint pieces that we can put in for you, for the original.
Yeah, I think, yeah, I just can't hear the audio very well right now. That's okay, I'll see if I get it from Dr. Ochoa.
Of course.
Okay, already added you to Teams, so you should be having access to it. Is there any other questions for the team?
Yeah, I've got a question. It's Jacob, by the way.
Go ahead, Jason.
Y'all's prosthetic, I know a lot of times with prosthetics, the user will wear a sock or something to cushion everything. I know y'all put some TPU on the bottom side for gripping purposes.
Yeah,
And even though Trey still has most of his foot and everything, you think about it like we wear soles inside of our shoes to cushion the blow when we're walking around so that we don't get our pains and aches. So did y'all think about or did y'all implement something like that to
Yeah.
cushion that when he's using the prosthetic?
Yeah, so in the phones when doing it, we were having issues trying to get one of the tips from the 3D printer to print with the TPU, but in our design, we have an inner layer that's specifically TPU so that he can have a softer inside, like a cushion. So what we were gonna do before we started doing the presentation day, and we were trying to think about how we're gonna get Trey here and adjust it to it. If the TPU wasn't working, we were just gonna try to get some memory foam just for the purpose of having that there, just to show kind of like what we're thinking. But yeah, on the inside, there's a layer of TPU, or there should be a layer of TPU, just like on the bottom, just so that he has a softer contact area.
yeah, the actual SolidWorks file has that inner layer. It's just, we couldn't figure out how to print with two different materials. So that's the issue we had. The actual SolidWorks file has a inner layer for the TPU.
Okay.
Okay, so if there's no more questions, thank you very much, guys.
Thank you.
Thank y'all.
Thank you.
Dr. Ochoa, did every team